Alright, for the next part of video homework, let's talk about problem 2. So in problem 2, we have a joint density function as fxy equals 1 over a y to 2x. And we know that y is larger than 1 and x is larger than 1 over y and smaller than y. So for the first question, we need to draw the definition region of f x y. Right. So in this question, we should consider these two conditions right here. First, we know that y is larger than 1. And x is larger than 1 over y. And x is smaller than y. So we can draw the figure like this. First, we need the two figure of these two functions. First is x equals y, and the second is x equals 1 over y. This is x equals 1 over y, right? And this one is x equals y. So, and this point, this intersected point is y equals 1 and x equals 1. So we know that y is larger than x, so it's this direction, and x is larger than 1 over y, it's this, oh shit. So it's this direction, so we know this part is the definition region of fxy. The second question asked us to find a so that joint density function is valid, right? So we can go to the definition of a valid joint density function, which is like this. We took integral to y and x. The result of this integral should be 1. Right, and we have all this definition region right here, so this integral should not be that difficult. We can transfer it to, for y is larger than 1, for x is larger than 1 over y and smaller than y. So it's like this. Do some calculation, math problem. This is 2, right? Because ln 1 over y equals minus ln y, right? So we can have this as the part of the result. But this is not easy to do the integral, so let's do some transformation. First let ln y to be m, so y is e to m. And the above equation should be like this one. 2. Right. And this is a much easier integral for us. 0 to infinity, because now we have to do the integral with m, right? Not e to the m. When e to the m equals 1, m equals 0. So this part we started from 0. And then we can have a function like a to 2, a 2 equals 1, and a equals 2. Okay. Then let's jump to question 3. Question 3 asked us to find and draw the marginal density function. Fx and fy. So with a joint density function fxy, how to get the marginal density function is also easy and is also covered in the lectures. So fy should be the integral to x, so it's we have y to 2 ln y. And from the definition region, we know that x is larger than 1 over y and smaller than y. So from x to y, we have something like y is larger than x and y is larger than 1 over x. Right, this is tricky, this part, because we have to, calculate it, or we have to transfer it in different situations. When x is larger than 1, and another situation is the x is smaller than 1. Right, because when x is larger than 1, oh, what is this? When x is larger than 1, we have x larger than x, 1 over x. When x is smaller than 1, 1 over x is larger than x, right? So when x is smaller than 1, fx equals x, 1 over x to infinity, which is 1 over 2. And when x is larger than 1, fx equals x to infinity, okay. So 3 questions down, and we still have 1 more. The 4th question asked us to verify if f and y, if fx and fy are valid. And this is also easy when we're trying to verify a density function. To see if it's valid, we have to do the integral of it from minus infinity to plus infinity of fx dx. For this part, we know that fx, this is definitely not 1, so fx is not a valid density function. And for fy, we have seen this part at somewhere else, right? So let's go find this y, which is right here, right? Because we know that this part is a valid density function, and the result of this integral is 1. So fy is a valid density function, and it has been proved in question 2. Yeah. Alright, that's all about the video homework. Thank you for watching.